Okay, we've got all the components there that we need now to run a simulation. So watch these steps carefully. I'll go as slowly as I possibly can. Now you'll notice that the AC signal source, alternating current, I'll talk to you about this on the board in a minute, we'll do a bit of theory in a second. But you'll notice that it's set to 60 Hertz. That doesn't matter because we're going to scan that anyway, so don't worry about the frequency, it's immaterial. But if you double click on it you can change the values, but it doesn't matter for our purposes. And it says that it's got 120 volts RMS going in there. And its root mean square. Don't worry about that either. It's just the absolute power in the AC signal that's there. Everything that we need is necessary. Everything that's necessary to be able to run the AC simulation is now there. So what we want is we want to ask multisim if it will very kindly scan from 0 Hertz to a few megahertz and plot a graph for us of the amplitude and the phase of that circuit there. Okay, so I go up to the top there and next to place, so we're not going to do place now, we're going to do simulate, and we're going to click on analyses and simulation. And the whole world opens up because we've got a window there with lots and lots of different simulators in there. Now look down that left-hand side there. Interactive simulation, DC, AC, transient, DC sweep, single frequency AC, Monte Carlo, noise, Fourier, temperature sweep, the list goes on and on and on. Pole zero, plots, transfer functions, all of these are pieces of terminology that you'll come across in electronics. I think probably the two most useful on there are the Fourier, and you'll do that in something or other theory, which is that you analyse what frequency components are there. We're not going to do that. We're going to do an AC sweep. We're going to effectively turn that signal generator from 0 Hertz up to a few megahertz. So let's do that. So we click on AC sweep, and you'll see on the right hand side there we've now got a series of options. Now I happen to know, only through experience, but I happen to know that a start frequency of 1 Hertz is fine. So 1 cycle a second, I can live with that. But do I really need to take a circuit with 1K and 1 microfarad up to 10 gigahertz? Probably not. 10 gigahertz is a pretty high frequency. So I think what I'm going to do there is I'm just going to click on the megahertz for the time being, and I'm going to go from 1 Hertz to 1 megahertz. Now if you do different, you'll just get different graphs, that's all, but it will become obvious in a minute why you need to get that scale correct. And you can do that by trial and error. So start frequency 1 Hertz, stop frequency 1 megahertz. Okay, so that looks good so far. Now let's have a look at the output. Now which one of those are we most interested in, or which ones are we most interested in? Well, I think it would be fair to say that IO1 is at the same connection as the signal generator, so we ought to know what's going in there. It's just an AC signal which has the same amplitude across all frequencies. The one we're really interested in is this IO3, because that's the output of the circuit, right? And again, I'll go through the theory of that in a minute. But you've got IO3, that would be interesting if we could have a look at that. So go over to here where it says all variables, click on IO3, and then click add. And you'll see that it's gone into that right-hand column. So now I've told the simulator that I wish to scan from 1 Hertz to 1 megahertz, and I want it to plot me a graph of IO3. Yeah? Job done. Let's press the run button down the bottom and see what happens, shall we? My word, look at this. Look at this. Well, what's happened there? So I said to you that that circuit was a low-pass filter, right? Look what it's doing. So at low frequency, you can see the scale at the bottom, that's the phase on the bottom, by the way. But you can see at 1 kilohertz, it's dropped almost, sorry, that's the phase change. You can see at 1 kilohertz, it's starting to go downhill, And by the time you get to 1 megahertz, there's almost nothing left. That's 100 microvolts there, and it started off on this scale at about 10 volts. So you can see what that circuit is doing is it's letting through the low frequency and it's blocking the high frequency. That's exactly the kind of filter that you have on your telephones. So on your telephones, you've got a deep voice like mine. I mean, I don't doubt I go above about 2 kilohertz. But most people, including females, can go up to about 8, 9, possibly even 10 kilohertz. But you don't want to hear anything beyond that, because that's just noise. It's high frequency noise. This is the kind of filter that you would use to remove those high frequency components. And look how easy that is to do. Look how easy that is to do. Okay, tell you what.